All right, let's dive into this slide, which focuses on Introduction to Kubernetes Security. This is a topic of paramount importance considering the pervasive adoption of Kubernetes in today's DevOps practices. Here we're going to cover the fundamental aspects of securing your Kubernetes cluster. Kubernetes, being a robust and flexible platform, supports a variety of native tools and methodologies to enhance the security of your deployments. It's your job as a cluster operator to thoughtfully implement these mechanisms, ensuring that your applications are not only performant, but also secure. We have to remember that security in Kubernetes is not an afterthought, but a continuous process of proactive management and routine checks. It forms an essential layer of your cluster's architecture. Deployed applications, data flow, user roles, and overall cluster health are some aspects of your Kubernetes environment that can be safeguarded with the right security measures. In this section, we would be picking apart Kubernetes security, offering you insights and best practices on how to maintain a secure environment for your deployments. So let's forge ahead. And remember, security isn't a one-time deal. It's a continuous and crucial part of your Kubernetes journey. Welcome to the slide on the Kubernetes introduction. Kubernetes is a widely acknowledged open source platform. It is tailored to automate the processes involved in deploying, scaling, and managing application containers. By using Kubernetes, organizations can run and manage containerized applications effortlessly. Yet it's important to underline that, like any system, Kubernetes is not impermeable to vulnerabilities. Without robust, effective security protocols and measures, a Kubernetes cluster could potentially be exposed to risks. When we talk about risks, it could be anything from a breach of confidentiality that compromises sensitive data to functional issues impacting system performance or stability. Moreover, vulnerabilities in the cluster can potentially enable unauthorized access or unsolicited intrusions, allowing threat actors to gain access and manipulate application data. This can also lead to unexpected service interruptions, for example, causing the API server to fail. Conclusively, securing your Kubernetes cluster becomes a critical aspect of managing and maintaining your applications and data on this platform. By doing so, we ensure the safety, integrity, and reliability of our service offerings and protect ourselves from potential data breaches. Now, let's delve into why Kubernetes security is such a crucial aspect. Essentially, it boils down to a couple of core scenarios. The first one being API server failure. Lack of adequate security measures in a Kubernetes cluster may inevitably lead to unruly API failures. These could further disrupt your services and applications running on this platform. The second key scenario revolves around unsolicited access. To put it simply, if your Kubernetes environment isn't secure enough, it could potentially become an entry point for intruders. These malevolent actors could gain unauthorized access to your application data, which could pose a significant risk. So, what implications could these situations have? Well, they can lead to some serious consequences, such as loss of essential data, or even worse, a breach of confidential information. Hence, it's crucial to take preemptive measures when it comes to Kubernetes security to prevent such outcomes from becoming a reality. This emphasizes the incredible importance of ensuring that your Kubernetes environment is as secure as possible. In this slide, we dive into the core of Kubernetes security, the basics. First off, let's discuss RBAC, which stands for Role-Based Access Control. RBAC is a system that regulates who has access and what actions they can perform in your Kubernetes environment. This is a key security feature in Kubernetes because it prevents unauthorized access and limits the extent of potential damage from an insider threat. On a related note, let's focus on network policies. Just like water and electricity in a city are regulated by a complex network of distribution systems, the communication between pods, the smallest deployable compute units in Kubernetes, are regulated by network policies. These policies determine which pods can communicate with each other, thus significantly reducing the possible attack surface. Lastly, we turn our attention to secure container practices. Containers in Kubernetes can be thought of like apartments in a huge apartment complex. Each of them has its distinct entity, but share the underlying infrastructure, such as plumbing or heating. In a similar vein, containers share the host OS and kernel. and hence it's paramount to ensure that these containers operate securely to prevent any widespread damage. By mastering these basics, RBAC, network policies, and secure container practices, you can set up a solid defensive foundation for your Kubernetes cluster. Let's dive into the details of Kubernetes Role-Based Access Control, or RBAC. So what is RBAC? Simply put, this is what manages who has the ability to access the Kubernetes API and what kind of permissions they are endowed with. Let's take a look at an example here to understand it better. If we start with a command such as kubectl create role, this would allow us to create a new role named podreader. The verb flag is followed by the type of permission that we want to assign to podreader. In this case, get. Next to it, we have the resource flag, which is followed by what the role can interact with. For this example, it's pods. Lastly, we mention the namespace flag, followed by the name of the namespace, in this case, example namespace. So, what we have now is a role, podreader, that can get or read pods within the example namespace. Moving on to our next command example, let's work with binding this role with a user. Utilizing kubectl create role binding, we can couple our role podreader to the user example user, specific to the namespace example namespace. Notice that we are using role equals podreader, user equals example user, and namespace equals example namespace flags respectively. By formatting our commands in this way, we ensure our user example user has the ability to read pods in example namespace only. So in summary, RBAC is a fundamental feature of Kubernetes, providing a sophisticated method of managing user permissions within various namespaces, enhancing Kubernetes security and access control. In this slide, we're diving deeper into Kubernetes basics, focusing on network policies. So what exactly are these network policies? Network policies in Kubernetes function to define how groups of pods communicate with each other along with their interaction with other network endpoints. Essentially, they set the ground rules for internal and external connections, thus managing communication patterns within and out of the cluster. The question now is, how do we use them? Network policies play an essential role in the isolation of your Kubernetes services from the outside world. This isolation is crucial in maintaining system integrity and ensuring secure data flow. Making the best use of network policies results in a Kubernetes environment that's optimized for both scalability and security, preventing unauthorized access and protecting your services. So, using network policies effectively is a key aspect of managing your Kubernetes services. Handling the communications within the cluster and with other network endpoints can prove instrumental in ensuring your Kubernetes environment remains robust and secure. Now let's focus on a crucial topic: secure container practices in Kubernetes. Why do we need to incorporate secure container practices, you may ask? Well, the answer is to ensure that the containers deployed within your Kubernetes clusters remain as secure as possible. Let's take a look at how we can increase this security level. First, it's highly recommended that you only use trusted base images for your containers. These trusted base images are typically created by reliable and trusted sources, which ensures that they're free from malicious exploits or vulnerabilities. Secondly, it's about limiting container permissions. In Kubernetes, this can be managed by using something known as a security context. Security context controls the permissions and identity that your container processes run with, effectively restricting the actions that they can carry out. Therefore, limiting such permissions can prevent breaches and unauthorized actions from causing serious harm to your clusters. By incorporating secure practices, you can greatly enhance the overall security of your Kubernetes clusters and reduce the risk of security breaches. On this slide, we're going to focus specifically on the execution of secure container practices via specific commands. A vital part of any secure container practice is to have full control over your container permissions. You achieve this by using the kubectl run command, as exemplified here. This command creates a barebone pod running nginx with the specified security context. As you can see, it runs the user and group under specified IDs and a certain file system group. This specified security context ensures that our nginx container runs with a unique user and group ID, different from the root or host user. Further, the FS group capability grants ownership and write permission to the user ID 1000 and group ID 3000 for any files created. The concept of auditing for sensitive data is also introduced here. The kubectl create secret command enables us to store sensitive data, such as passwords or tokens, securely within Kubernetes. As seen in the example, we're creating a basic secret named dbpassword, and from literal, we're setting the password. These practices contribute significantly to your overall security measures, allowing for safer and far more efficient Kubernetes landscapes. As we delve deeper into secure container practices, we will focus on some crucial techniques in this section. These techniques will fortify our container security and reinforce our defense systems. The first major technique we're going to examine is the regular update and patching of containers. Just like any software system, containers can also have vulnerabilities. This potential issue can be simply resolved by ensuring that your containers are always updated with the latest patches. Regular updates and patches not only provide you with new features, but also fix known security vulnerabilities, ensuring your system stays secure. The second technique involves the use of security plugins like AppArmor or SecComp. These software solutions reinforce the security of your containers by restricting their capabilities and access. This can help prevent exploitation of potential weaknesses in the system. The third technique we'll discuss is the use of static analysis tools that target container vulnerabilities. These tools identify and analyze codes in your containers for any weaknesses or vulnerabilities, and then provide custom defense methods. Using static analysis tools to analyze container vulnerabilities aids in maintaining a secure environment by proactively identifying and mitigating risks. To sum up, there are various techniques to secure your containers, ranging from regular updates and patches, employing security plugins, to using static analysis tools. Each of these methods reinforce your container's security by limiting possible network attacks and identifying vulnerabilities that could potentially be exploited. Implementing these techniques forms an essential part of maintaining secure container practices. On this slide, we're going to delve into Kubernetes security and discuss some of the best practices that will help you emphasize security in your Kubernetes environment. First and foremost, it's important to adopt a strategy of regular updates and patching. Keeping your systems up to date is a fundamental part of every security protocol. When Kubernetes releases an update, there are potentially crucial patches that secure vulnerabilities. They might have addressed any number of bugs or issues that could be exploited by malicious actors, so ensure these updates are applied in a timely manner. Next is segregation of duties and implementing the principle of least privilege. Basically, you want to limit the power any individual has within your Kubernetes environment. It reduces the risk of accidental or intentional damage. Tasks should be broken down on a need-to-perform basis, and individuals or teams should only have the minimum levels of access necessary to complete their assigned tasks. Finally, be sure to enable role-based access controls, or RBAC. RBAC is an approach to restricting system access to authorized users. In the context of Kubernetes, RBAC helps you control who can access the Kubernetes API and what permissions they have. By using RBAC, you can set policies on a fine-grained level to enhance the security posture of your cluster. Following these best practices will strengthen your Kubernetes environment and significantly reduce the potential risks. Diving straight into our conclusion, the importance of Kubernetes security. A common misconception is that security is a feature that can be added in as an afterthought. To the contrary, in a truly secure system, it must be an integral part of the design process from the beginning. In the context of Kubernetes, we should not be simply applying security measures after designing and deploying our clusters. So what does this mean practically? Well, it all comes down to making sure that the design of your Kubernetes clusters is inherently secure. Every aspect, from the operating system it runs on to the configuration settings and even the deployment practices, should be guided by security considerations. In short, security should not be viewed as a mere addition or enhancement. Rather, it becomes a core feature that needs to be built in, not bolted on. So, as we develop and maintain our Kubernetes clusters, let's always keep this principle in mind. Security is not an afterthought, it's a primary thought in the design process. On your screens now is a critical resource compilation that can serve as your reference guide to fortify your understanding of Kubernetes security. Firstly, we have the official Kubernetes documentation found on their website. This go-to resource breaks down all the security concepts and components of Kubernetes. Ensure that you visit the link on the slide to keep abreast of any updates or changes. Our second resource is focused on Kubernetes security best practices. Published by the Cloud Native Computing Foundation, CNCF, this blog delves deep into efficient and secure strategies for employing Kubernetes. Again, make sure to visit the link provided in the slide for substantial insights. Lastly, we have the Docker Security Handbook. Although Docker is not Kubernetes, they often work in conjunction, and understanding Docker security measures can greatly aid in securing your Kubernetes clusters. The link to reach this security guide is also included in this slide. Note that these resources are fundamental tools to deepen your knowledge and understanding of Kubernetes security design, implementation, and best practices. Please do consider exploring these references for an all-encompassing perspective of Kubernetes security.